Let's use the multiplication rule for independent events. Well, what is an independent event? Well, we're really thinking of having two events. Okay, so if we have event A and event B, it simply means that the probability of one event does not affect the probability of the next event. Because we know that sometimes called the domino effect, right? When one thing's happen, it impacts the next thing. Well, if one does not affect it, then we call those events independent because they are creating their own outcome or their own next thing. So if A and B are independent events, that means when we are finding and, right, because and is our multiplication rule, we simply multiply probability of A times the probability of B. So if they're independent, we multiply. You toss a fair coin and roll a fair six-sided die. What is the probability of flipping a heads and rolling a number larger than 4? Now, when you think about, are these events independent? Well, if you're flipping a coin and rolling a die, I mean, I guess you could flip the coin and it could hit the die and that would like impact one. But in general, if you just flip a coin and roll a die, one has no effect on the other. So we would say, okay, these are independent events because one does not impact the other. So we would say the probability of heads and a number larger than 4 would be the probability of heads times the probability of a number larger than 4. Okay, so what is the probability of flipping a heads? Okay, there's two sides to the coin, heads and tails. Heads is one of those, so that would just be a 1/2. On a fair six-sided die, we have 6 numbers, 1 through 6. A number greater than 4, there are 2 of them. So the probability would be 2 out of 6. Multiplying fractions, we can say, okay, well, notice we have a 2 in the numerator and denominator. We can reduce. 2 goes into 2 one time. So I'm left with 1/1 times 1/6. And this multiplies, right? Multiply straight across. So the probability of flipping a heads and rolling a number greater than 4 is 1 out of 6. Let's do another. You have red cards numbered 1 through 9 and black cards numbered 1 through 9. What is the probability of choosing a red 6 and a black card with an even number? Assume these are independent events. Okay, so we're trying to find the probability of a red 6 and a black even number. And they tell us these are independent. So we're going to say the probability of a red 6 times the probability of a black even number. Now let's think through this. If we have numbers 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 of them. So a red 6 is just 1 out of 9 because we're talking about red 6s, right? If I'm choosing from a red card, the probability of choosing the 6 is 1 out of 9. Then if I go to the black cards and I want an even number, so 1, 2, 3, 4. There are 4 even numbers out of 9 in the black set of cards. So I'm looking at 1/9 times 4/9. And if I look numerator to denominator, can I simplify or reduce anything? No, because in the denominator I have 9s and in the numerator I have a 1 and a 4. 4 does not divide evenly into 9, so we're golden. So I just multiply straight across. 1 times 4 is 4. 9 times 9 is 81. So the probability of choosing a red 6 and a black even number would be 4 out of 81. And I believe that is playing with multiplication rule and independent events.